So hello guys, today we are going to talk about Pico hydropower turbine. So before we go into our system, let me introduce to you our group members. So I'm Divakaran, metric number 192472. Together with me, we have JAZLAN, metric number 192202. We have AMANI, 195599, IZZAT, 192299, and also we have ULWAN or NASIH, 192316. So without a further ado, let's move on into our agenda today. So today we will be talking about introduction of our system, where we'll be talking about overview of our system, objective and problem statement. Later we will talk about market analysis and target people. In here we will talk about hydropower projects in Peninsular Malaysia and location. Later we will move into methodology, how we complete this assignment. Discussion where we'll be focusing into simulation results, wiring design requirement, and what are the constraints and limitations that we face during the completion of this project. At last, we will talk about business plan, how the market analysis, product and service that we plan to provide, the marketing plan, logistic and operational costs, and also we will talk about financial plan and cost. So let's, for the first section, introduction, I would like to call Amani upon to introduce, call Amani to talk about our overview and our problem statement.
So for electricity transmission and distribution costs are quite high, and they mainly serve the urban areas, which means that the ones who reside in remote communities could struggle with the limited electricity supply. Hence, it can make the sustaining a successful teaching and learning environment quite challenging. So since Malaysia is a country with mountainous landscapes and also a sufficient amount of rainfall, water sources could be quite accessible. So hence, we use the Pico hydro power generation system, which is a technology that claims to be able to produce electricity from free hydro resources, which can be also sold to consumers at a very low cost. So the objectives of this project, which is to provide a 3,000 watts electricity that requires a limited electricity supply using Pico hydro power generation system, and also to produce a clean energy for those who reside in rural areas, and also to implement an affordable system that will accomplish a sustainable teaching and learning environment. So for the problem statement, maintaining successful teaching and learning is an aim that wishes to be reached by many communities. Some challenges can be encountered while achieving that. Due to the outbreak, many institutions had to implement the online teaching and learning to minimize the social interactions and to reduce the chances from spreading the virus. Unfortunately, few institutions believe that it's quite challenging to deliver sustainable teaching and learning for some students, especially for those who reside in rural areas, due to the fact that electricity might be limited in these areas. Therefore, we are required to resolve this issue with implementing an affordable system that will supply sufficient electricity to those who are less fortunate.
So thank you, Amani, for the introduction. So for the second part, market analysis and targeted people, I would like to call IZZAT to explain about this.
Assalamualaikum and hi everyone. My name is MOHAMAD FAKIHIN IZZAT, and for my presentation, I will start with the market analysis and targeted people for this Pico hydropower project. First of all, this table is representing the hydroelectric scheme in Sungai Perak, starting from 1930 to 1998. With the various installed capacity and energy output. This data obtained from the Department of Irrigation and Drainage of Malaysia has proved that Sungai Perak has a good potential to have a development in hydropower projects in the future. From the previous table, we also can see there are a good number of large hydropower projects as well as the small hydropower projects whose operations are based on the runoff river. Which is the one that we are going to develop. The rivers in Peninsular Malaysia are very small and not well suited to provide the base load energy if compared to the rivers in the state of Sarawak. However, the rivers in the Peninsular Malaysia are considered well suited for small hydropower projects. Perak is also the largest existing hydropower scheme with the total installed capacity of about 650 megawatt. For the targeted people and area, we have chosen Perkampungan Orang Asli Sungai Teras from the article news that we found from Masro Awani provided by Simi Muhammad on 16th of August 2020, where he reported that the village had to live without electricity for 60 years.
So thank you, Izzat, for explaining to us about market analysis and the target area. So from this point, methodology, I'll take over first, and then later will be continued by our friend Izzat again. So for this methodology part, So for this methodology part, we have separated into 4 sections, which is analyzing the problem, planning the solution, calculation, and business plan. So for this business plan, I'm not going to talk about it under our methodology because our friend JAZLAN will talk about it later at the end of this session. So let's move on into analyzing the problem. Among the renewable energy available, we analyze which one is the most suitable that can be placed into the target area. So as we have seen, the target area is surrounded by village trees, so it is not windy. So wind power plant is automatically out of option. It was sunny for our solar power plant, but it is not spacey. Plus, we know that solar power plant is much more expensive compared to hydro power plant. Plus, the target area has a river nearby, and it is under the hill, so we can get good and clean water flow from the river. So from this approach, we have come up that hydro power plant will be our best. It will be our better approach compared to solar and wind. We plan our solution first by creating a block diagram. So for this block diagram, it contains DC motor charge controller. It contains battery, inverter, and also our loads. Our loads are lights, ceiling fans, switching socket outlets. So these are our loads. So before we explain about this further, let's look into the components that is involved in the design of the hydro power plant. So this is a Pico hydro power plant. What does Pico hydro power plant mean? When we talk about small generation of electricity using water, hydro, so there is actually 4 levels that we can say, like small hydro, mini hydro, micro hydro, and pico hydro. So what does pico hydro means? It provides only up to 5 kilowatt of electricity. So as you can see from the design, we do not have a powerhouse to store big amount of electricity. So it is like you generate it, you use it straight, or you save it, you charge your battery. That is all the use of the Pico hydro. You cannot be using for long transmission. So the components for the design is actually water tank, which act as reservoir during the dry season. Penstock pipe, or we can call it supply pipe. This will make sure that our water coming out from the water tank will have a high pressure jet that can push our hydro turbine. The most important is our generator, which will generate electricity from the kinetic energy of our hydro turbine, and electronic controller. It's actually electronic controller. So electronic controller needed to make sure that the voltage, that the supplied voltage is not going up and down. So it is regulated into this one. This is important for the load, so that constant energy is supplied to the load rather than going up and down. So later, I have explained about the operation of the Pico hydro system. At last, distribution system will connect the electricity directly into from the generator into the loads in houses or rechargeable battery, and there is no bigger powerhouse to contain this energy. So we have also bring out our Simulink model, which is the same flow as we have explained earlier. So for this calculation part, our friend Izzat will continue on this.
Next, we will look into the calculation of the overall system. First of all, we assume that the water flow rate range from 6 to 10 meter cube per second, with the generator efficiency ranging from 60% to 70%. the distance from the generator to the battery and houses uh, with the 100 meters, and the distance of the head of 30 meters. We also consider the power losses in generator and penstock and inverter, with the efficiency also assumed to be 60% to 70%. The power output obtained from the calculation with the flow rate of 10 meter cube per second and the head distance of 30 meters is the 2943 watt. Therefore, for the 70% efficiency, we obtain 2060.1 watt. This is the floor plan for the houses located in the Perkampungan Orang Asli Sungai Teras, with the loads are the lighting, ceiling fans, and sockets. For the calculation in distribution board design, we have come up with three different MCB value, which is 16 ampere for 13 M socket, 10 ampere for lighting and fan, 6 ampere for the toilet lighting. The MCCB rating size also valued to be as 16 ampere. For the business plan calculation, JAZLAN will be explaining on the next session. I think that is all from me. Thank you.
So thank you, Izzat, for completing the methodology part. So next, we are moving into discussion part. So for this, we are calling Amani to continue into our project requirements.
So when it comes to this project requirements, a few criteria must be met in order for the generator to function properly and also to provide a sufficient amount of electricity, which first will be about waterproofing the DC generator, since it's going to be surrounded by water, and also to make it resistant in order to prevent any damages for the generator. And also, since the water source can contain rubbish and unwanted or unnecessary objects, it could harm the turbine. That's why we need to install a drainer. Next, we need to make sure that the flow rate is powerful enough in order to produce a minimum of 500 watts. Also, we need about two 12 volt storage batteries and also 65 ampere hour connected in series, which produce an output of 1560 watts. And lastly, during any faults, a protective relay is used to trip the circuit breaker, and also a safety relay can be used to detect any fault contributors such as overheating or over voltage. And then for the limitations of this project, we have the flow rate changes, since there could be factors such as heavy rain and also heavy rain could also impact the flow rate of the water. And also, since when it comes to constructing a Pico hydro system, it doesn't cost much, but the maintenance of the project can need a considerable amount of funds. And also, as we said earlier, we need to install a drainer in order to prevent or to stop these rubbish and unnecessary objects from entering the turbine. And last, we have the COVID-19 pandemic. For the situation, unfortunately, we weren't able to visit the targeted location to collect enough info. So that's why instead we tried to look for researches and also online searching. That's all.
Thank you, Amani. So now we will move into simulation part. We call upon NASIH for this.
My name is ULWAN, and I will start my presentation on the simulation. So my first simulation is on the hydro turbine generator model. So this is to simulate when the water flow to the turbine blade that rotates the generator. It will convert from the mechanical energy to the electrical energy. So assuming about 4.5 meter of mechanical power being applied to the turbine blade, and it will cause about 327 RPM of rotation on the generator. So the output voltage from the generator will be 230 volt DC with 13 ampere of current, which is equivalent to 2 kilowatt of power generated. Next, move on the charge controller. So our charge controller have a few main function. Firstly is to prevent the reverse current flowing back to the generator. So we use the diode to prevent to the diode will allow the current to flow only in one direction. Next is the ID switch. So when the generated power is greater than the demand, than the load, so the ID switch will be closed and the charging process will start. And if the demand is higher than the power generated, so the switch will be open and it will stop the charging process. The battery also will stop charging as it approach 100% of its state of charge. We are charging this our battery with 0.7 ampere of current. It will take about 3 hours to fully charge. So from our charge controller, we can prevent the reverse current flowing back to the generator, and also we can prevent the overcharging of the batteries. So we can prolong our battery life. Next is on the inverter. So this inverter, we use this model with 4 IGBT diodes because we want to produce a pure sine wave. So from our simulation, we get to produce the 230 volt AC voltage and also 2.5 ampere of current. So this pure sine wave that are being produced is the same as the waveform delivered by the utility. So we can also see that the harmonics are virtually eliminated, and this will ensure that the appliance, all the appliances that are connected can be operated properly.
Okay, next part is the business plan. So first part in the business plan is market analysis. So in 2020 until 2025, market for hydro turbine expected to be expand about 2.5%. In 2018, hydro is the largest source of renewable energy, about 15.9%. And from the figure, you can see that Asia Pacific contribute the biggest amount of hydro turbine, about 41%, especially in China. So next is product and service. So our product is by using a 3000 watt DC generator, Pelton turbine, 12 volt battery, and also a inverter to convert DC to AC source. So our service is to give people in Kampung Sungai Teras to have an access of electricity such as lighting from the battery. We also provide three 13 ampere socket for charging a laptop, smartphone, and also to watching a television. Next is marketing plan. So we estimated the price for our product is about 1,228 ringgit. The product name is a Pico hydro turbine, and the place for the installation, of course, at the Kampung Sungai Teras, Perak. Okay, the logistic and operation plan, we divide into 4 parts: supplier, facility, shipping, and also inventory. So for the supplier, the generator and turbine, we buy it from the Thermodyne System Company and Global Hydro Energy. We can reduce the shipping cost by buying our equipment online using Shopee or Lazada. Next is a financial plan. So this is the total cost installation for Pico hydro turbine in 4 house. We after calculating, we get about 4,112 ringgit in 4 house. Then we divide by 4 so we get about 1,224 ringgit for installation in per house. So next is this is the cost for electrical usage by following the TNB specification. From this table, we can see that by using the Pico hydro turbine, we can save about 25 ringgit per month for the electrical usage cost. Okay, lastly is for the net profit for product. So by consideration of the rent, also the salary, and also uh, rent, salary, and also the work salary, we get the net profit for this product is about 815 ringgit.
All right, thank you, Jazlan. So that's all from us. We would like to reach our gratitude towards our lecturers, Dr. Nazim and also Dr. Samsul. Also, we would like to thank Dr. Nasrin for supervising us. Thank you for this wonderful opportunity. So now we can move on to our Q&A session. Thank you.